Now the next question says, factorize the following expression completely. To factorize this expression, all we have to do is factor out the highest common factor. The highest common factor is 4n. Factoring out 4n, we end up get 3n minus m. First one done. We never do nothing hard really. That factorize. Next part say, show that x over 1 minus x minus 4x is this. So the first thing we need to do is on our left-hand side, we need to join it as one fraction. So we need to use LCM. So you have minus 4x. And remember, when it's just minus 4x by itself, it's over 1. So you have to find your LCM. Your LCM is going to be 1 minus x. 1 minus x into 1 minus x goes one time. So 1 times x is x. Then you put minus 4x. They put in bracket 1 into 1 minus x goes 1 minus x. 1 minus x times 4x, so you put 1 minus x here. So now we just need to simplify this. Now to simplify this, this is going to be equal to x minus, now 4x times 1, that's minus 4x squared. So it's going to be x minus 4x plus 4x squared. All I did was expand in the minus. Inside right there, I expanded in the minus. So I'm doing it really slow so we can see. And then now x minus 4x, that is just going to become x minus 4x. That's negative. That is negative 3x. And this part is 4x squared. So x minus 4x is negative 3x. So I'm going to put the 4x squared part first. And then I put my negative 3x. And then that is being divided by 1 minus x. And then, of course, what I can do is factor out. I can factor out my x. And by factoring out my x, I'm left back with 4x minus 3. This was easy. That's the numerator over 1 minus x. And that's how we do this proof right there. Can tell them so that did nice. I never bad. Now it says hence solve this equation. Since it says hence, what the word hence mean is instead of using this side to solve the equation, hence mean you're going to use the other side over here and solve the equation. So instead of solving this part equals 0, what we're actually solving then is this part equals 0. Because look at it. Down here, so if you're solving this equals 0, you can solve that part equals 0 since the two of them are the same. Yeah, man. So that's what we're going to do. So we're going to solve this part that we just found equals 0. So we're going to solve x times 4x minus 3 over 1 minus x equals 0. And if this is equal to 0, now bear this in mind. The only way something can be 0 is if the numerator is 0. The only way this is 0 is if the numerator is 0. So that implies we can either get x times 4x minus 3 equals 0. We ignore the denominator. We ignore the denominator because the denominator can't be 0. So solving the numerator part, we get x equals 0 or 4x minus 3 equals 0. And from this side, we'd end up get x equals 3 over 4. So the two answers are x can be 0 or x can be 3 over 4. Those are the answers. All right. So again, just to put it in a box, x can equal 0 1 answer or x can equal 3 over 4. Again, we ignore the denominator because look, 0 over 5, right? That's a 0. And the numerator alone can be 0. But if we put the denominator as 0, let's say 5 over 0. You don't know what this is. Put this in a calculator, we don't know. So anytime a number is 0, it's because the numerator is 0, all right, and not the denominator. Next part says to make v the subject of this formula. First thing we can do is square both sides. So when we square both sides, it end up get p squared is equal to 5 plus v times t. And then since we need to make v the subject, we can bring over the 5 to get p squared minus 5 is equal to v times t. And we want v to be the subject, so then we divide both sides by t. So we divide both sides by t now. We divide both sides by t. We divide both sides by t. This t cancels this t. All right. And that's it. So end up get v is equal to p squared minus 5 over t. That's when we transpose it. That's your answer. This wasn't bad at all. Nice. That's our answer. Yeah, man. Nothing too hard. Now, the next question says, the distance needed to stop a car D. The distance needed to stop a car D varies directly as the square of the speed. So they're telling us that the distance is equal to k times the speed. Let me not even start with equal. It varies directly as the square of the speed, s squared. So if d is proportional to s squared, what they're telling you is d is equal to k times s squared. All right, and then it says a car traveling at a speed of 70 required a distance of 40 to stop. So what that means is when the distance is 40, well, look at this now. They're giving us the speed, right, in kilometers per hour. So we can do this. So it had a distance of 40, and 40 is equal to some constant times the speed of 70 square. So the only thing we need to do now to get rid of the 70 square to make k the subject is we divide by 70 square. So when you divide by 70 square, what I want you to do is just put that in your calculator, 40 over 70 square. So put it in our calculator. So put in our calculator 40 over 70 square, which is this right here, a very small number, that is k, that's your constant, all right? That's your proportionality constant. K is 8.6, so that is k. K end up being 8.6 times 10 to the minus 3. 8.6 times 10 to the minus 3. So then now the question says, what is the distance required to stop a car traveling at 80? So the distance is going to be equal to the constant k times the speed square, 80 square. All you have to do is put this in a calculator now. So we'll take out our calculator again, multiply it by 80 square. And so what we end up getting is 52.2. That's 52.2. So we can, oh shoot. All right, I'm just gonna write it back real quickly. My apologies, it came off. So that's the constant times the speed square. And we end up got that when we had plug in the distance of 40 is equal to the constant k times 70 square. We end up got that k was equal to 40 divided by the 70 square. And then we end up got that k was equal to 8.16 times 10 raised to the minus 3. And then we went over here and end up find the distance d for when it is k times now 80 square. And we end up get that the distance is, just to pull up back the calculator, 52.2 52.24 meters. It didn't tell me how much decimal place to round it off to, so I'm just going to work with that. All right, and that shall be that. Nice.